So we're now going to do a little bit deeper dive into the way that parallel streams works internally with respect to splitting, combining, and pooling. And this, again, follows all along with our general philosophy of knowing what you can control and what you can't control. And it turns out that you'll control some things through collectors and spliterators, and then you can control some stuff through the ManagedBlocker, although we'll talk about that. We've discussed that earlier in the context of the common ForkJoinPool. So the splitting, combining, and pooling mechanisms are invisible unless you choose otherwise. So it's like ninjas. You can't see them unless they want to be known. And as it turns out, you can control the splitting phase by spliterators that are defined on the collection interface. Remember, with Java 8 and beyond, they started having this concept in interfaces called default methods. Prior to Java 8, an interface could only have basically method signatures, but no method implementations. And with Java 8, they added this concept of a default method, which allows an implementation to be provided, which, unless it's overridden by a class that implements the interface, will be the implementation. And that's the way this works. So by default, you get a spliterator, which comes out of the box using a predefined spliterator, which may or may not be the optimal thing to do. So as a consequence, a lot of concrete collections actually customize the spliterator. And we'll take a look at some of those examples later. Then there's also this parallel stream and a stream factor method that will use the stream support.stream utility method to take the spliterator for the object and then pass in the parameter true, which basically says, go ahead and make this a parallel stream. So that's how parallel streams, it's one way that parallel streams come into existence. There's also the collectors interface we talked about before, and this has a bunch of predefined methods. You can also have method implementations that are static in an interface. That also came with Java 8. And so in this particular case, we have toList and toSet, and these return non-concurrent collectors, but of course, non-concurrent collectors can also work with parallel streams. So this is a very, very common thing. Even for streams that are parallel streams, you can still use all your favorite types of collectors. And there's also worth pointing out that there's now a terminal operation that works for both streams and parallel streams called toList, which is basically a sort of a subset of what you get with this toList version in the collectors utility class, because it creates an immutable list that can't have its values changed. So it's also a very common thing to use. Then the third piece of the puzzle is the common ForkJoinPool, which is used to run all the intermediate operations on chunks of data. We already know that. So let's go ahead and talk about how you can customize this stuff. So as we've said before, you can define your own spliterator, which will implement the spliterator interface. And we've talked before about how try-advance is used for sequential streams, and of course also for parallel streams, but they're used after everything's split up into chunks to then deal with things that are left over. And then the most important method for parallel streams that we haven't spent as much time on is try-split. And this is the method that's used to partition the elements up in a parallel stream. I gave you a somewhat contrived example much earlier on when we talked about spliterators initially in the context of sequential streams, and I gave you a hokey example that wasn't very satisfying. And I said at the time, this gets much more interesting when it's used with parallel streams. So that's what we're going to talk about. We're going to take a look at some examples of how to use this. And basically, the idea is, if at all possible, you want to split things evenly and efficiently. If you can take a data structure, a data source, and split it evenly and efficiently, life is a lot better. There's also the collector that accumulates stuff into a mutable result container, which is either thread safe for concurrent collectors or sequential non-thread safe for non-concurrent collectors. And we'll talk about that, and I'll show you a bunch of examples. We've also talked about this before, so this is just a quick recap. There's the ManagedBlocker mechanism, which we talked about in the context of the common ForkJoinPool. And that's the one place where you can get a modicum of control over what's going on in the apply phase. So you really can't influence too much the ordering in which things run in the apply phase, but you can control whether there's extra threads that are created in the apply phase. And that's done by using the ManagedBlocker. So I'm not going to talk a heck of a lot more about that, but be aware for your assignment for assignment 3B, the parallel streams assignment, you will once again be using a ManagedBlocker because, unlike assignment 3A, where it was a sequential stream, now we've got a parallel stream, and so we need to be sensitive to the fact that there could be more images to be downloaded than there are threads available in the common fork join pool by default. So a ManagedBlocker will help to expand the number of threads if that's something that is actually necessary to do. All right, so that's the end of this discussion. This is kind of a bit of a recap, but I'm setting the stage for where we dive into the details of this in the context of parallel streams.